Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 1 of 10 good problems on the chapter of linear equations in one variable. Uh, as I always come up with 10 good problems as and when a chapter is completed in the other playlist CBSE Maths 8 RS Agarwal. So if you have not watched all the theoretical videos and problem solving in that playlist on the chapter of linear equations in one variable, I strongly suggest and request that you watch those videos to get a good understanding of the concepts of linear equations in one variable. So this video is part of the playlist Maths 8 Hot, where HOT stands for High Order Thinking Problem, where I come up with 10 good problems from various competitive examinations and as well as the NCERT exemplar textbook, not textbook, exemplar problems book that covers a good variety of questions. Solving these 10 good problems will definitely give you a good judgment on your understanding of the concepts of the chapter. So if you are new to my channel or not yet subscribed, or if you are watching my videos for the first time, I strongly request and suggest that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 10 good problems of set 1 on the chapter of linear equations in one variable. Okay, so I have the 10 good problems on the left hand side, and on the right hand side canvas I will solve the problems. I have switched back to Mac, which is a very slow machine, and it gives problem while I write. But I have reduced the resolution of the monitor, which might be the cause of slowing down the writing process. Let me see. I have no idea how it will go. Hopefully, it will not be as bad as the last video when I was recording. It was really very horrible experience. Let's see how it goes. So as usual, you must always try to solve these 10 good problems yourself first, preferably in 40 minutes, that is approximately taking 3 or 4 minutes per question. And only if you are stuck in solving a problem, you refer to this solution video to have to uh, to see the solution and the concept that was applied to solve the problem. And also it is highly recommended that you have completed the chapter, you know all the concepts, and you have solved quite a bit of problems from the textbook, whichever textbook you are following, and then only you solve these 10 good problems, because these problems are a bit relatively harder than the normal problems that you see in the standard textbook. Okay, so let's get started in solving the problems. Okay, the problem one says that if x equals to a, then which of the following is not always true for an integer k? Okay, so it is given that we have x equals to a, which is a kind of equation where on the left hand side LHS we have a variable x, and on the right hand side we have the constant a. It is a convention that the variables are denoted or represented by the letters x, y, z, and the constants are represented by the letters a, b, c, d, a, b, c, d. So from this equation, it is asking that can we have, let's check all the options one by one. It is asking whether from this equation can we have kx is equal to ak, where k is some integer, where k is some integer. Where k is some integer. Okay, it is asked, the question is then which of the following is not always true. So we have to choose we have to select the choice which will not always be true based on the fact that we have x equals to a and k is an integer. Now regarding choice a, if k is an integer, we can always multiply both sides. We know that in solving an equation, as a rule of as one of the rules to solve a linear equation, we can always multiply both the sides by the same number. So in this case, it is okay that we can multiply both the sides with k, and we will always have this will always be true, that is kx is equal to ak will always be true for an integer k. So this is this is true, so definitely it will not be a correct choice. This is true, this is correct, I mean not correct in the sense this is not the right answer, but this statement is true, that is kx equals to will be equal to ak where k is an integer. Let's see B. X divided by k is equal to a divided by k. Now, here is a problem, because nothing has been said about nothing specific has been said about the integer k. It is only said that k is an integer. Now, if k is 0, certainly this will not work, because we never divide by 0. This will break, this will crash, or we will have a problem. So definitely this we cannot say that x by k will be equal to a by k for an integer k, because if we consider k equals to 0, we cannot divide, we cannot even divide any x by k or a by k. So this is a false statement, this will never be true. This not never be true, but this will not be true for k equals to 0. Since this is the wrong statement, since this option B will not always be true, because it will not be true for k equals to 0, I can say, we can immediately say that the correct choice is B. I am not even checking the choice C, because we clearly see that choice B will not always be true, because for k equals to 0, this will not be true, that is x by k equals to a by k, this will not hold, because if k is 0, x by k is undefined, we never divide, in arithmetic we never divide by 0. So the answer is B. Now for the choices C and D, they are also correct statement, because we know that as a rule of solving linear equation, we can always subtract or add the same constant on both sides. So based on that rule, choices C and D, they are also correct statement, and hence they are not the correct answer. Okay. So after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Okay. Let's do problem number 2. Solve for x. Okay, so we have an equation, we have to solve the equation. The equation is x by 2 plus x by 4 plus x by 5 plus 10,000 is equal to x. So we see that both the sides are having the variable x, that is the unknown x, which we have to solve, and on the left hand side there are 3 rational terms. Rational terms means of the form p by q, where all the denominators are constants, and the denominators are 2, 4 and 5. 2, 4 and 5. Now whenever you have in an equation, whenever you have any term, a rational term, where the rational term there is a variable either in the denominator or in the mostly it will be in the numerator, then I always ask then I always suggest that you you multiply both the side of the equation by the LCM of all the denominators of the rational terms. So in this case also, I would like to, my method would be, my suggestion would be, even though there are various ways of solving an equation, my way would be to multiply both the sides of the equation by the LCM of all the denominators of the rational terms. And we see that the denominators of all the rational terms are 2, 4 and 5, and their LCM is definitely 20. Their LCM is 20. So I would like to multiply both the sides. I am writing a little slowly, because so that the handwriting does not get weird, because the machine is slow. I have to write a little slower. Okay, so I have x by 2 plus x by 4 plus x by 5 uh, plus we have 10,000 uh, equals to 20x. So we have multiplied both sides by 20. Why 20? Because 20 is the LCM of the denominators of all the rational terms, that is x by 2, x by 4 and x by 5. Now if I do the product on the of the LHS, if I simplify the LHS, that is I will multiply 20 with all the terms inside the bracket, and it becomes 10x plus 5x plus 4x plus this is a big number, this will be 20 big numbers, okay, and we have 20x. So this is the equation we got. Now we will gather all the variable terms, that is the x terms, to the left hand side and all the constants to the right hand side. Constants to the right hand side, and we get 10x plus 5x plus 4x minus 20x is equal to minus, how much is this? I think it is 2 lakh. Anyway, so whatever it is, 5 zeros. Okay. Doing further a simplification of the LHS, that is adding up the x terms, we get 10x plus 5x is 15x, 15x plus 4x is 19x, and 19x minus 20x is minus x. So we get minus x is equal to minus 2. Now what is how many zeros are there? There are 5 zeros. So minus 2 multiplied by 10 to the power 5, since in the choices we are having some powers of 10. This implies x will be equal to 2 to the power 10 to the power 5. Hence the correct choice, this is the value of x, that is the solution or root of the given equation, and hence the correct choice is D. D is the correct choice. Now one thing to note is that if you are given an equation where you see some rational terms, but none of the rational terms are having variable, the variable which need to be solved, then you need not multiply both, you need not find the LCM of the denominators of all the rational terms and multiply both sides with the LCM. You just since all the variable terms, that is x terms or whatever letter it is, will be in the linear form, you just gather all the variable terms to the left hand side and gather all the constant terms to the right hand side, and then you simplify the right hand side. So simplifying the right hand side, possibly you will have to do some addition and subtraction of rational numbers. Okay. Let's solve question number 3. Let a and b are positive integers. Okay, then the solution of the equation ax equals to b is always, okay, so the equation given is ax equals to b, where it is given that a and b are positive, that is a is given to be greater than 0 and b is also given to be greater than 0. Then it is asking, then the solution of the equation is always. Now what will be the solution of the equation ax equals to b? It is simple. This implies x will be equal to b by a. Now we have to see what will be the nature of the value of b by a. Will it be positive, will it be negative, or will it be 1, or will it be 0? Now it can never be it cannot be 1 or 0 because nothing has been said about the specific value of the a and b. So we need to concentrate whether this b by a, this rational term, since a and b are positive integers. Okay, so a and b are positive integers, so definitely a is not equals to 0. So we can so it is a kind of, it's a rational number. It is a rational number. Now, since it is so the solution is b by a. Now, now we have to see whether b by a is positive or b by a is negative. Certainly, we can say that b by a will be positive as b is greater than 0 and a is also greater than 0. So if you divide, this is a very common sense, a fundamental thing, that if you divide a positive number by a positive number, the result is positive. And that is in the division of two numbers, if both are positive or both are negative, the result is positive. The result is negative only when one of them is negative. So the correct choice will be positive A. A is the correct choice. Okay, let's do problem number 4. It is given the sum of three consecutive multiples of 7 is 357. Then the smallest multiple is. The sum of three consecutive multiples of 7 is 357. Now, what are three consecutive multiples of 7? So let's try to understand that first. If the smallest number is 7, definitely since it is consecutive multiples, the next multiple of 7 will be 14, and after 14 the next multiple of 7 will be 21. So 7, 14, 21 are three consecutive multiples of 7. If we start with, let's say, 28, let's say if we start with 28, that is 28 is the smallest multiple of 7, then what will be the next multiple of 7? It will be 35. That is, you just add 7 to 28, and then the next multiple of 7 will be, you just add 7 to 35, that is 42. So this is meant by three consecutive multiples of 7. Now, so we have to find such three consecutive multiples of 7 such that their sum is 357. Now, clearly we can see, if we assume it has asked to find the smallest multiple. Now, as you can see, the smallest multiple will be a multiple of 7, and the very smallest multiple of 7 possible is 7. But we do not know whether in the three consecutive multiples of 7 whose sum is 357, in that three consecutive multiples of 7 the smallest one will be 7 or not, we do not know. So we can assume that let the smallest multiple of 7 in the three consecutive multiple of 7 be, we can say 7x, because any multiple of 7, any natural number which is a multiple of 7 has to be of the form 7x, where x is some natural number. So that is the reason we are assuming that the smallest multiple of 7 in the three consecutive multiples of 7, let that be 7x. So this implies three consecutive, no, my machine is giving still the same problem, three consecutive multiples of 7 are 7x. The next multiple of 7 will be 7x plus 7, and the next multiple, that is the largest multiple of 7, will be 7x plus 14. So these are the three consecutive multiples of 7 where we have assumed that the first multiple, that is the smallest multiple of 7, is 7x. The sum of the three consecutive multiples of 7x is given to be 357. So we can say 7x plus 7 plus 7x plus 14 is equal to 357. So this is the equation we have formed, which now we have to solve for x. Once we have found x, we can say that the smallest multiple of 7 will be 7 into x. Now to solve this equation, we proceed as usual. We keep the variable terms, that is the x terms, to the left hand side and bring all the constant terms to the right hand side, and we get 7x plus 7x plus 7x is equal to 357 minus 7 minus 14. So this implies the LHS becomes 21x is equal to 357 minus 21, which is equal to 336. So this implies x is equal to 336 divided by 21. I hope it will divide properly. Let's see. 1, and then we have 12, 126, and it is 6. So x is 16. This implies smallest multiple of 7 which has been asked, smallest multiple of 7 will be equal to 7 multiplied by 16, which is 112. So 112 is the smallest multiple of 7, and hence the next multiple of 7 will be 119, and then 126. So 112 is the smallest multiple of 7. So the correct choice will be A. A is the correct choice. Okay, let's do problem number 5. Let PQR be three consecutive integers whose sum is 156. Then the number which is a multiple of 13 is. Okay, so among the P and Q and R, it has asked which of them will be a multiple of 13. Okay, so PQR are three consecutive integers whose sum is 156, which means then it has asked, then the number which is a multiple of 13 is the choices are P, Q, R, and none of these. So okay, so P is the smallest among the three consecutive integers. P is the smallest one, Q is the middle one, and R is the largest one. So let's say let so we have to basically find the three consecutive integers whose sum is 156. So let the consecutive numbers are, since they are consecutive, we can say if we assume that the smallest number is x, then the next number will be x plus 1 and the next number will be x plus 2. Okay, so this implies their sum is given to be 156. So we have this equation, we have this linear equation, we have to solve for x. So we get 3x is equal to 156 minus 3. This implies 3x is equal to 153, and this implies x is equal to 153 divided by 3, which is equal to 51. Now the question is, which number is a multiple of 13? Now 51 is definitely not a multiple of 13. 51 is not a multiple of 13. Okay, So among the P, Q and R, we have to choose which one is a multiple of 13. So we have found that in as per our assumption, P is X, Q is X plus 1 and R is X plus 2. So we have found X. So this implies P is equal to 51. Q will be 51 plus 1, that is 52, and R will be definitely 52 plus 1, which is 53. Now we have to see which numbers P, Q and R is a multiple of 13. Clearly we can see that 52 is the multiple of 13, as 52 is 13 into 4. So Q is equal to 52. So hence the correct choice will be Q, that is B, choice B. Okay, let's do problem number 6. In a two-digit number, digit in units place is twice the digit in tens place. So let the digit in units place is twice the digit in tens place. So let tens digit, let's tens digit be X, that is X will be a digit, that is values, it will have values, it can take values from 0 to 9. B X. So this implies units digit, it is given that the units digit in the number is twice the digit in the tens place. So it will be twice X, where we have assumed the tens digit is X. So the number will be of the form X and 2X. So 2X is the digit in the units place, and X is the digit at tens place. Okay. If 27 is added to it now, so this implies the number is equal to X 2X, which in the expanded form is 10X plus 2X. 10X plus 2X. As we know that in a two-digit number of the form AB, where B is the digit at the units place and A is the digit at the tens place, in the expanded form it is 10A plus B. So the number will be 10X plus 2X, which is 12X. Now it is said that it is given if 27 is added to it, the digits gets reversed. Okay. If 27 is added to it, the digits gets reversed. Okay. So so it is given that X, when the number, original number was of the form X and 2X. If you add, it is given that if you add 27, the number is becoming, the digits get reversed, that is the number becomes 2X and X. That is 2X becomes the digit at tens place and X becomes the digit at units place. This is the basic information. Please note, this is not the linear equation. This is just a mathematical representation of the given fact. Now, this implies, we can say that now in the expanded form, so this is the original two-digit number, and this is the same number when the digits are reversed. So when when 27 was added to the original number, the new number, which is the new number in the new number that is formed in that new number, it is the original number, but the digits are reversed. Now if we expand the two numbers, we get 10x plus 2x, that is the original number, plus 27 is equal to is equal to 10 into 2x plus x. This is the new number formed when the original number was added with 27. So this is the equation we have formed. This is now the linear equation that we need to solve. Okay, and we will get x, and from that x we can say that the question has asked about then the number is, that is the original number. Okay, so now if we solve this problem, we have 12x plus 27 is equal to 20x plus x. This implies if we bring all the, so this is equal to 21x. Now if we bring all the x terms to the left hand side and all the constants to the right hand side, we get 12x minus 21x is equal to minus 27. Now this implies minus 9x is equal to minus 27. This implies x is equal to minus 27 divided by minus 9, which is 3. So x is 3. So this implies the original number is equal to, this was the original number. So the original number is 3 and 6. So 36 was the original number. Hence, the correct choice is D. D is the correct choice. Okay, let's do problem number 7. It is given that 1 lakh is rupees 1 lakh is divided into two parts of rupees 500 notes and rupees 1000 notes. If the total number of notes is 175, then number of rupees 500 notes is. Okay, so the total amount of the money is rupees 1 lakh and it has been divided. So it is made up of, it is divided into two parts of so one part will have 500 notes and the other part will have 1000 notes. And it is also given that the total number of notes, that is the total number of notes of 500 and 1000 is 175. Then we have to find what is the number of 500 notes. Okay, so let's say let number of rupees 500 notes be x. So this implies, since it is given that the total number of notes is 175, then we can say that the number of rupees 1000 notes will be 175 minus x. So 175 minus x is the number of rupees 1000 notes, where we have assumed x to be the number of rupees 500 notes. So this implies total money will be equal to x. There are x number of 500 notes, so x multiplied by 500 plus there are 175 minus x number of 1000 rupees. So we will have 175 minus x multiplied by 1000. So this is the total amount of all the notes, total value of all the notes in rupees. Okay, and it is given that the total amount is already given to be 1 lakh. So we can say that 500x plus 175 minus x multiplied by 1000 is equal to the total amount is given to be 1 lakh. This. Okay. Now, if you see in an equation, if you see there is a common term in both the LHS and RHS, then you can factor that common, sorry, not common term, but common factor in both the LHS and RHS, then you can cancel that out, cancel that common factor from both LHS and RHS. I can clearly see that I can take 500 common factor from the LHS, and it becomes the LHS becomes 500 multiplied by x plus 175 minus x multiplied by 2, and also the RHS is 1 lakh. I can take 500 common, and I can say it is 500 multiplied by 2. How much is this? There must be 5 zeros. Okay, so this is 500 multiplied by 200. Now I can see there is a common factor in the LHS and RHS, and I can cancel that out. And so the equation becomes x plus 2 into 175 minus x is equal to 200. Now, further simplifying the LHS, that is doing the product of 2 and 175 minus x, and opening the brackets, we get x plus 175 multiplied by 2 is 350 minus 2x is equal to 200. This implies x minus 2x is minus x is equal to 200 minus 350, which is equal to minus 150. So this implies x is equal to 150. So x is 150. What is x? X was, we assumed x to be the number of rupees 500 notes, and hence the answer is 150. It has asked the number of rupees 500 notes. So the correct choice is C is the correct choice. Okay, let's do problem number 8. Which of the following is true if the solution of the equation is an equation is given is 1 by a minus b. Solution means if you solve the given equation, the value of x that you will get, that is the solution or root of the given equation. So the given equation is ax by b minus bx by a is given to be equal to m. Okay. Now it is saying that which of the following is true if the solution of the equation is 1 by a minus b. Now, okay, now if we try to solve this equation, so this is now this is an equation. We do not know a and b and m. There must be some constant, and we see some rational terms on the LHS, that is ax by b and bx by a, they are rational terms. They are having denominators b and a. Now, I hope you know that the LCM of two constants whose values you do not know, that is they are represented as literals, in this case a and b, but actually they represent some constant values, that is their values do not change. The LCM of a and b is always ab. Just like you know that the LCM of two the LCM of a and b will always be ab. So as I have discussed that if you have in an equation, if you have rational terms where at least one rational term is having the variable x, then you find the LCM of the denominators of all the rational terms and multiply both the equation by the LCM. So in this case we will since we have two rational terms ax by b and minus bx by a, we have to find the LCM of A and B. Even though we do not know the specific values of A and B, we always say that the LCM of A and B is AB. So then if we multiply the both sides of the equation by AB, so we get AB multiplied by the LHS, which is AX by B minus BX by A is equal to ABM. ABM. Okay. Now, if you simplify the LHS, that is, you distribute the multiplication over subtraction, you get AB multiplied by AX by B minus AB multiplied by BX by A is equal to ABM. If you further simplify the LHS, you get A square X minus B square X is equal to ABM. From the LHS, we see if you take X common, we have X and A square minus B square is equal to ABM. Okay. This implies that X is equal to ABM divided by A square minus B square. So this is the value of X, or the solution we got from the given equation. Now it is also given that the solution of the equation is 1 by A minus B. So we can say that 1 by A minus B is equal to ABM divided by A square minus B square. Now ABM divided by A square minus B square, the denominator A square minus B square can be, okay, so we have this. Okay, now we can do cross multiplication. We can do cross multiplication and equate the, from cross multiplication, applying cross multiplication, we can say this is equal to A square minus B square is equal to ABM multiplied by A minus B. Okay, now this implies that the choices are given, all the choices are some relation between M, A and B. Okay, the LHS A square minus B square can be written as A minus B multiplied by A plus B is equal to A, B, M and A minus B, and we can cancel out both. We see common factors A and B on both the sides, and we can cancel out A minus B, and we get A plus B is equal to ABM. So this is the relation we got between A, B and M, and we have to choose the correct choice, and clearly we see that C is the correct choice. C is the correct choice. Okay, let's do problem number 9. It is saying for what value of M the root of the two equations are same. So two equations are given. Let us first write the two equations. Xm plus 2 is equal to 2xm plus 3. This is the first equation. And the second equation given is minus x by 54m is equal to minus 4m. So definitely from this two equation we will get the solution. We will get some solution of the two equations. That is, this equation, the first equation will have some value of x, and the second equation will also have some value of x. Now It is the question is for what value of m the root of the two equations are same. So it is saying that the root of these two equations, this is the first equation and this is the second equation, the root are same. That is, we will first find the root of the both the equations and we'll equate them. From that, definitely we can find the value of m. So let's first solve find the solution of the first equation. So we have, if we bring the x terms to the left hand side, we get xm minus twice xm is equal to 3 minus 2, which is equal to 1. This implies minus xm is equal to 1. This implies x is equal to minus 1 by minus 1 by m. So this is the root of the first equation, that is minus 1 by m. Let's solve the second equation. This is pretty straightforward. We can directly say that x will be equal to minus 4m divided by the coefficient of x on the LHS, that is the coefficient of x is minus 1 by 54m. If you simplify the RHS, it is minus 4m multiplied by the reciprocal of minus 1 by 54m, that is minus 54m. Now minus minus cancels out, we get minus minus cancels out, we get 54 multiplied by 4, which is 216 and m square. Okay, so the solution of the second equation is 216 m squared and the solution of the first equation is minus 1 by m. It is given that the roots of the solution of the two equations are same. So we can say minus 1 by m is equal to 216 m square. Okay. Now this implies, now from here we got an equation in m and we have to solve for m. Okay. Now 216 m square, we can always consider it as by 1. Now if you do cross multiplication, applying cross multiplication, we get minus 1 is equal to 216 m cube. That is not that is 216 m square multiplied by m, which is equal to 216 m cube. This implies that m cube is equal to minus 1 by 216, minus 1 by 216. This is equal to, we know 1 by 216 is 6 cube. Now this implies m is equal to cube root of minus 1 by 6 cube, which will be equal to minus 1 by 6. The concept is that the cube of a negative number is, you know, that minus cube of minus x is equal to negative of x cube. Also, cube root of minus x is equal to negative of cube root of x. Considering x as a positive number, then minus x will be a negative number and cube root of a negative number is always a negative number. So we have m equals to cube root of minus 1 by 6 cube, 1 by 6 cube, that is 1 by 6 cube. You can say that cube root of negative x cube is always equal to minus x. Now the answer is coming. So for this you have to be very strong in. You must have a good understanding of the cube roots, cubes, and square roots and squares. So you must have completed the chapter of square roots, squares and square roots, and cubes and cube roots. If you wish, I have already covered those chapters in the other playlist, that is CBSE Maths 8 RS Agarwal. You can watch those videos from that playlist. Now the answer is coming to be, m is coming to be minus 1 by 6, and in the choices we are having minus 6. I think I think minus 1 by 6 is the correct answer. Let me check once again. The second equation, that is minus x by 54m is equal to minus 4m. The solution we are getting is x is equal to minus 4m divided by minus 1 by 54m. Yeah, that is fine. So the solution of the second equation is 216m square. Okay, that is fine. The solution of the first equation is 1 by minus 1 by m. So minus 1 by m is equal to 216m square, and we are getting m cube is equal to minus 1 by 216. Okay, this is fine. I think I made some mistake in providing the choices in the question number 9. Sorry, it's my problem. It's my mistake. So the correct value of m is minus 1 by 6. Minus 1 by 6. Okay, let's do the last problem, that is problem number 10. So we have to an equation is given in where the variable is y, and it is asking the value of y. So basically we have to solve the equation. So the equation is 19 minus 7y divided by 15 minus 3y is equal to 18 plus 11y divided by 5 minus y. Now clearly we see that there are rational terms in the equation, and there are two rational terms. This is first one, this is second rational terms, and they both have the variable x in the rational terms, and the denominator also is having the variable y. So we cannot say we cannot find the LCM of the denominators. So but you can see, if you observe that from the denominator of the first rational term, that is 19 minus 7y, from the denominator, that is 15 minus 3y, I can take 3 as a common factor, and I get 3 multiplied by 5 minus y is equal to 18 plus 11 y by 5 minus 5 minus y. You see that both these two rational terms, both the rational terms are having 5 minus y as the denominator, as a common factor of the denominator. Now as I said that the LCM of a and b is always equal to a multiplied by b. Also LCM of a and 3a, let's say 3a is 3a. I hope you are getting the idea. So this concept must be very clear. Also let's say LCM of let's say 4a and 6b will be equal to the LCM of 4 and 6 multiplied by a and b. The LCM of 4 and 6 is 12. So it will be 12ab. Okay, so now we see that the equation is having two rational terms, where both the rational terms is having the denominators are 3 into 5 minus y and 5 minus y. So we can say that the LCM of 5 minus y and 3 into 5 minus y is equal to 3 into 5 minus y. So we can multiply both the sides with 3 into 5 minus y. So this is one way of doing. The other way of doing is that you can bring the second rational terms to the left hand side and simplify the two rational terms, that is having the variable y. You must be very familiar with let's say with addition and subtraction of this kind of rational terms, where both the rational terms are having some variables. Let's say y by 1 plus y minus, let's say, 3 by let's say 2 into 1 plus y. How will you do the subtraction? So clearly the LCM of the denominators will be 2 into 1 plus y, and in the numerator it will be 2 multiplied by y minus 3. So this kind of addition and subtraction of rational terms, where the rational terms are having some variables, you must be very familiar. I hope you have already done this. You have already studied this in your previous classes. So I will not bring the second rational term to the left hand side and simplify, but rather I would like to multiply both the LHS and RHS with the 3 into 5 minus y, which is the LCM of the two denominators of the two rational terms. Hence, we get, if you multiply both sides by 3 into 5 minus y multiplied by the LHS is 19 minus 7 by 3 into 5 minus y is equal to, we will multiply 3 into 5 minus y with the RHS, which is 18 plus 11y by 5 minus y. Now if you simplify and do the products, you will see the LHS becomes 19 minus 7y, and the RHS becomes 3 3 into 5 minus y multiplied by 18 plus 3 into 11y. So this implies 19. If you do further simplification of the RHS, it becomes 18 into 3 is 54. 54 multiplied by 5 minus y plus 3 into 11 is 33. So 33 y. Okay. Now again we have to do a little further simplification of the RHS. That is 54 multiplied by 5 minus y. 54 multiplied by 5 is 270 minus 54 y plus 33 y. Now I will bring all the y terms to the left hand side and all the constants to the right hand side, and I get minus 7y plus 54y minus 33y is equal to 270 minus 90. Now after doing further simplification, that is adding the variable terms on the LHS, we have minus 7y minus 33y is minus 40y. So minus 40y plus 54y is 14y. 14y is equal to 270 minus 19 is 251. Okay, so this implies y is equal to 251 by 14. So 251 by 14 is the solution of the given equation, and hence the correct choice is D. D is the correct choice. So this brings to an end in solving the 10 good problems of set 1 on the chapter of linear equations. I hope this set of problems will give you a good practice of your understanding of the chapter concepts, and this video will be beneficial to you. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So I will keep on making and solving more sets of 10 good problems from this chapter. So keep an eye on this playlist, that is Maths 8 Hot, where I will keep on making 10 good problems and solving them from various chapters as and when they are completed in the other playlist, that is CBSE Maths 8 R.S. Agarwal. So thanks for watching, and until the next video, take care and bye.